Assalamualaikum and hi. I am Nurul binti Osman and my partner Izzati binti Muhammad Isa are the final year students under the supervision of Encik Mak Rosli Mak Daud will present on our final year project entitled Analysis of Curve-fitting Models for COVID-19 Cases in Malaysia.
I'm Nurul Izzati binti Muhammad Isa and this is our supervisor Encik Mak Rosli bin Mak Daud.
First, let me start with introduction. Based on research from World Organization Health, WHO, coronavirus is a large family of viruses that can cause illnesses in animals and also in humans. There are a few illnesses involving this virus such as Middle East Respiratory Syndrome MERS, Severe Acute Respiratory Syndrome SARS, and Coronavirus Disease 2019 COVID-19. In November 2002, SARS-CoV was identified as first-century pandemic which originated from an animal market in Guangdong Province, China, and had spread to over 30 countries in about 8 months. This pandemic had gone through 3 phases. First, in March 2003, this outbreak was involved by a large number of hospital staff and medical students in a teaching hospital. Second, this pandemic has greatly spread in community in Amoy Gardens. The last phase was in May, where this virus has spread in a large scale in 8 hospitals and more than 170 housing estates throughout the city, but in middle June. In the second decade, there was another disease detected as a second coronavirus named MERS-CoV. This disease was originated in the Middle East and had infected over 2,000 of individuals worldwide. The highest number of cases was in Saudi Arabia, and most of the cases that are reported outside of the Middle East were related to people who traveled in Arabian Peninsula or close contact to already infected cases. In this study, we will focusing more about coronavirus disease 2019 COVID-19. At the end of December 2019, WHO had discovered new virus called coronavirus disease 2019. Infected people were having difficulties in respiratory system, same as MERS-CoV and SARS-CoV. This ongoing outbreak of COVID-19 has claimed 80,129 confirmed cases lives in Malaysia as of 16th of October 2020 at 16:11 hours according to WHO. There are many studies use the suitable software and tools to model the data. For example, BI and Lang in the study used software named FirstOp and its Liebenberg-Marquardt optimization algorithm to fit the equation for SARS, MERS-CoV and COVID-19 data. The data that is used for the modeling is from WHO and the National Health Commission of the People's Republic of China. Next model is SIR, Susceptible Infected Removed Models. The model is used to analyze the behavior of the early spread of the infectious diseases. The model represents the number of people in each compartment at a particular time. The model is similar to SEIR, Susceptible Exposed Infected Removed, but the incubation period has been added. The important attributes were summarized, which are origin and its transmission. However, in this research, we will only focusing on mathematical models that has been proposed based on the COVID-19 data in Malaysia, which are linear model, parabola model, Gaussian model, and sine wave model. Then, I will proceed with problem statement. In this report, we are interested to know about the pandemic's behavior and how they have spread over the factor of time only. Other factors such as not wearing masks, having a gathering in crowded places, and hygienic factors are excluded. Next, by determining the best model, it can help our government to take a quick action against COVID-19. The government can make decisions from the analyzed models. Furthermore, the recognition pattern for COVID-19 can be easily obtained. We will know the way it has been spread over the time and able to predict the future by using the suitable model with suitable method. The reason why we need such models is to help us encounter the same problems as we never know what will happen in the future.
Next, the objective of our project. There are 3 objectives of our project. First, to analyze the pattern of COVID-19 number of positive cases in Malaysia. Second, to model the data of COVID-19 cases using curve-fitting model. Third, to determine the model that fit the data. Significance of study. This study is about creating data of COVID-19 that published by Ministry of Health regarding active cases in Malaysia. As we gather all the information, we can determine the best model that fit the data. The finding will hopefully benefit those related parties in order for them to plan a strategy to fight with COVID-19. Hence, by using this model, those who are in charge are able to predict the number of cases in the future. Scope and limitation of study. This study is focused on data that published by Ministry of Health in Malaysia. The data was collected from 3rd January 2020 until 16 October 2020. The scope is to fit the four models, which are linear model, parabola model, Gaussian model, and sine wave model. While for limitation of study, we have to decide which one among the models that best fit the data based on R square. And the data is only include time factor. Besides, data is only analyzed by using Origin Pro 2031 tools. Methodology of the project. There are 5 steps of methodology in our project. First, data collection. Second, data analysis. Third, analysis suitable method. Fourth, curve fitting analysis in Origin Pro. And 5, comparing the models. For step 1, data collection, we collect the data from Ministry of Health in Malaysia. It is secondary data. Step 2, data analysis. In this project, we will discuss 4 curve fitting model, which is linear model, parabola model, Gaussian model, and sine wave model. Step 3, analysis suitable model. This is a few steps of analysis these 4 suitable model. Step 4, curve fitting analysis using Origin 2021. In this step, we will calculate the R square, which is coefficient of determination for each models. Step 5, comparing the models. We will compare the 4 models based on the R square, coefficient of determination.
Next, we move to the implementation of these 4 models. For the first step, we need to load the COVID-19 data obtained into the Origin Pro 2021. The data is obtained from Ministry of Health Malaysia. Then, a workbook will appear as shown in the figure here. Basically, for the first step, we use the same way for all the 4 models. Next, we create the mathematical model for curve fitting for the 4 models. Firstly, for linear model, after we load the data, under the analysis step, we have to choose fitting, and then linear and open dialog. For parabola, under the analysis step, we need to choose fitting and polynomial fit. Differently for Gauss and sine wave model, we have to choose fitting and non-linear curve fit. Then a dialog will pop up as shown in the figure here, which is known as category and function selection dialog. By clicking the OK button, the required data will be selected for the regression analysis for linear and parabola model only. There is a difference in obtaining the result for Gauss and sine wave model, where under the function selection, we need to select the suitable category and function. For example, for Gauss, the category is origin basic function and the function is Gauss. And then, by clicking the fit button, the regression analysis will be generated. Lastly, we have to analyze the result obtained. For linear model, we obtain the result for R square, value for F test, and also the value for A and B to satisfy the equation. For parabola model, the result is given by R square, value for F test, and also the value for A, B, and C. For Gauss model and sine model, we obtain the result for R square and also the result for Y naught, X, C, W, and A. The output is also given by a graph with fitting line respectively.
Next, result and discussion. For result and discussion, we will look for residual sum square, percent R correlation coefficient, R square coefficient of determination, and adjusted of R square. For residual sum square, which is sum of square of vertical deviation from each point to the fitted regression line. The data is perfect if RSS is equal to 0. The smaller the RSS, the better the model fit the data. Next, for percent R correlation coefficient is widely used coefficient measure the strength of the model. The value of percent R constrained from -1 to 1. The closer the value to -1 or 1, the stronger the linear correlation. Next, for R square coefficient of determination, which is statistical compute to qualify the model. The closer the R square to 1, the more fit the data. Adjusted R square is modified version of R square, which is altered the number of predictor. It can be used to compare the fitted line with the different number of predictor. And the most important one is that R square must less than R square. But for this project, we will look only for R square, coefficient of determination. From the equation, A is the intersection while B is the slope. From that table, we can see the R square, which is 0.15126. The curve fitting is parabola model. From that table, we can see that the R square is 0.27835. This is the curve fitting for Gaussian model. From that table, we can see that the R square is 0.82947. This is the curve fitting for sine wave model. From that table, we can see that the R square is 0.18163. In conclusion, Gaussian model is the most fit model because the R square is the closest to 1.
In conclusion, secondary data were collected from Ministry of Health Malaysia's website. In this research, we successfully determined the most fitting model to the data by comparing the R-square value between linear model, parabola model, Gaussian model, and sine wave model. The method is also proves that it can be used to analyze the pattern of COVID-19 number of positive cases in Malaysia. From our report, we obtained Gaussian model is better than other models based on the R-square value. The research is fully based on the factor of time and no other factor is included.
Lastly, recommendation. Data collection should include other factors such as not following SOP and not wearing masks. We also can extend the time of cases to check the effectiveness of the models. Besides, we also can try to visualize using other countries' data. Lastly, we can compare the number of COVID-19 cases before and after the introduction of vaccine. That's all from us. Thank you.